With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
A small particle of mass m and its retaining cord is spinning with angular velocity omega on the horizontal surface of a smooth disk. As force F is slightly relaxed, R increases and omega changes. Determine the rate of change of omega with respect to R. Okay. So in this figure, we have certain tension in the cord. That tension is equal to tension in the cord is equal to the force. Okay, and that tension is again responsible for holding this particle of mass m at this position. Okay, and it will be applied by certain centripetal force that is equal to mr omega squared. Okay, so that will be cancelling out the tension in the string, that as T. So we will have F is equal to, F is equal to T tension, which will eventually be equal to mr omega squared. Okay, this is kind of our first relation. Okay, and now according to the question, mr omega squared. Okay, now this F is slightly changed. Suppose this F is increased by some amount. F is increased. So suppose initially it was F1 and it increased to F2. Now what we will have for F2, or increased force F2, we will have F2 that will produce a different tension in the string that we name as T2 is equal to, mass will remain constant, mr, and radius will change slightly, that r2 into omega also will change. So omega is omega to the square. Okay, so this is the relation for second. But what we need to understand here is that after we have increased the force from F1 to F2, then its angular momentum will remain constant. Okay, so after reaching the force F2, after changing F1 to F2, okay, so when F2 is in equilibrium with the tension and the centripetal force mr omega square, then we will have angular momentum constant. Okay, here one thing to be noted down is that the angular momentum when F is equal to F1, then angular momentum is not equal to the angular momentum when F is equal to F2. Okay, that does mean that in the previous case when force was F1, then the angular momentum at that point is not equal to the angular momentum when force is increased to F2. Is that angular momentum after we have reached the force is equal to F2, then then after that the angular momentum will remain constant. Okay, so for constant angular momentum, we have the formula for angular momentum, let's denote this by J, is equal to mass times R squared into omega. Okay, that mass times R squared is also denoted by I into omega. Okay, so this is the angular momentum we have. Now, this angular momentum will remain constant after we have reached the increased force that is equal to F2. So, J is equal to mr squared omega. Okay. Now, dividing it with respect to, or now differentiating it with respect to r. So, dj by dr is equal to 0. Why? Because it is not changing with respect to r. So, and we can write dj by dr is nothing but d of mr squared omega by dr is equal to 0. That will lead us to m is constant, so that will come outside the box and will give us m into d of r squared omega by dr, that is equal to 2r omega plus 2r omega plus r squared d omega by dr. Okay, which is equal to 0. Now, so from here we have r squared d omega by dr is equal to minus times 2r omega. Further solving this for dr by d omega by dr, we have d omega by dr is equal to minus 2 times omega divided by. This is the correct expression for the rate of change of angular velocity omega with respect to the radius. I hope you enjoyed the video.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut App today.